Okay, I'm gonna get started. So welcome to the stream, everyone. This week I'm gonna be playing with using compute shaders to do a particle simulation of flocking and swarming behavior. So I'm probably gonna start with just like a simple, well-known model called the Boyd's model. Um, so last week what I did was I just got a basic system in place so that I could use a compute shader to draw into a buffer and then display the buffer as a texture. So I'm going to be building on that this week so that I can make the compute shader draw the results of a particle simulation. So the model I'm going to be starting with is there's this paper from 1987 called Flocks, Herds, and Schools: A Distributed Behavioral Model. And I haven't read through it all yet. I was gonna kind of work out the details on stream. So but before I really get into that, I need to set up some preliminary technical stuff. So currently the situation is I have two stages in my pipeline. I've got the compute shader that doesn't take any input yet, and it simply just writes a bunch of output into a texture. And then I've got another stage in the pipeline that takes in the texture and then draws it to screen using a quad. So what I need is, I think I'm going to introduce another compute shader that runs first over a buffer that has particle data stored in it. So okay, so the first thing I need to do is create that buffer. So what I'm going to use is, right now I have a texture that I'm using from the compute shader and the regular fragment shader. I'm going to make something called a SSBO, which is a shader storage buffer object, which it's more general than a texture. It's less image-like and just can basically store any type of data. So I'm going to, right here, I need to call the buffer particles, and then I need to gen buffers. And I'm just creating one buffer. So that creates my particle buffer. I bind it, and then I can fill with data. So let me just take let's say this particle buffer, and then I'll just call my CPU set buffer particles. So let me think. The data I'm going to start with is just an x and y coordinate for each particle. And I'm just going to put them next to each other in the buffer, so like xy, xy, xy. Can an SSBO have like vectors in it? I need to look at what possible formats there are. Let me look at the docs for GL GL buffer data. So it's going to be a shader storage buffer, and I think think I want to use dynamic draw or dynamic read or something. Yeah, modified repeatedly and used many times. So GL buffer data, and then the buffer type is going to be you might, yeah, I need to look. Okay, so oh yeah, I forgot I have my chat overlay up, so I don't have to read off chat messages. We got Russell and Charlie and Sintel in the chat. Okay, so Russell asked, don't you just try to struct like for a uniform? I think so, but I think that's in the shader. And then, okay, Charlie's asking, does using Rust get you that much first? It seems like most of your code is in shaders and raw unsafe calls. I mean, at the moment, most of the actual substance of what I'm doing is in the shaders. So it wouldn't really matter what I'm using that much. And the fact that most of it is unsafe calls means those calls may as well be written in C. But like, I don't know. I still think even if there's a lot of unsafe in your Rust code, it's still worth using Rust. Because, like, if you're using a vector in an unsafe block, like, it's still bounds checked. Unless you do something weird, like get it as a pointer and then dereference that pointer. So, like, cargo is another great argument. Yeah, like, I think cargo by itself is an argument to use Rust over C for something like this. Okay, yeah. So, yeah, it is true that for applications with a significant amount of unsafe, it feels a little bit weird to argue for using the memory safe language over just C, but like I still think there's a lot of benefits. Okay, so let me, what was I doing? It's a shader storage buffer. And then the next arguments are the name of the buffer object, the size in bytes, and then the data pointer, and then I'm just gonna say, I don't think it matters that much, but I don't know whether I need dynamic draw, read, or copy. Modified by reading data from the GL and used to return that data. Okay, I'm just gonna say draw. Dynamic draw. Doesn't matter that much. Okay. Buffer size data. So buffer is particle of buffer size, and then so this should be okay. So now I need to fill up my buffer with just a bunch of particles. So let's say I start with 1,024 particles, and I'm just gonna pack in 2 floats, 32-bit floats next to each other for the x and y. So that's 2 times 2024. And then I can just say, so just like a size of on a vec or on a slice, or, and I'll just use for now. So, I need to look this up. Yeah. All right. Let me just see if it builds. Yeah, I just capitalized the F on accident. 5 arguments were supplied. I gave it the type, the buffer. Oh, yeah, you bind buffer. Don't give it as an argument. the state machine of OpenGL. Oh, these aren't arguments. Yeah, they are. Bind buffer. Oh, I passed shader storage buffer both. That makes sense. Expected eye size. So let me just cast that to an eye size. One thing about using C APIs from Rust is that you realize how massively inconsistent C APIs are about like integer types, because it doesn't really matter in C because it'll just coerce everything for you. Okay, and then I gotta cast the pointer to C void. Oh yeah, this gotta be mutable. Okay. So yeah, like especially in OpenGL, there are a bunch of places where the constant you need to use, like the enum constant for a particular argument, is unsized, and then the function you pass it to takes a unsigned, and then you pass it to a function that takes a signed, and that's just how OpenGL is and has been for almost 3 decades now. Yeah. It sucks, but on the other hand, it's easy to make bindings for, so who's to say if it's good or bad? Alright, I've made my buffer. I think eventually I actually want to have, because the particles, when I update their positions, they're going to be needing to read from multiple other particles in their neighborhood. So that means I need to have 2 buffers that I'm ping-ponging back and forth. So like frame 1 is in buffer 1, and then frame 2's results go in buffer 2 and read from buffer 1, and then back and forth. So just like a double buffer situation. So, but for now I'm just gonna draw particles based on a single buffer and then see what happens. So now I have my buffer data. I'm gonna make a new compute shader for the, wait, no, this one should be taking the particles, because this shader is for drawing the particles into a texture. So I use program, and then I give it a texture to draw to. Eventually I'm gonna start, because this is just like kind of a mess right now. Eventually I'm gonna start putting things kind of more encapsulated into structs. Like I already am doing that with program in a kind of nice way. Like you pass it a slice of shader stages. Read write buffer in, is that an OpenGL thing? Is that on the, or do you mean GL read write? I think that specifies how you are binding it when you use it with a shader. Whereas the dynamic draw thing is more like, it's like a hint for the driver how you want it to be allocated. Like if it's stream draw, that means you're pushing at every frame. So maybe the driver might choose to put that in an arena and linearly allocate and then drop it every frame, rather than if it's dynamic draw, then it might use more like a malloc type of allocator. Sorry if that wasn't your question. Okay, yeah. So what I was showing was I have this little like RAII style abstraction for shaders and programs, and like the drop clears up the resources and stuff. And eventually I'm going to do that with my buffers, and I actually think Rust does start to shine in those cases. You can do the same thing in like C++, but Like already I'm creating a shader in a safe way. Like there's no unsafe here, so. A bit confused. My phone and my laptop are showing different sets of messages in the chat. Gonna try to figure out what's going on. Okay. All right. So back to what I was doing. I'm making a second. No, yeah, I'm not making a second shader yet. I am giving the shader access to the SSBO, which means after the use program, I want to give it to it as a uniform. So I need to put a new uniform in my compute shader. So right now I have this one. So going back to shader storage buffer. Yeah, okay. This is what Russell was talking about. Okay. If you mean a single read-write buffer instead of reading from one writing to another, it would be a disaster for perf. You actually can do it that way. Like, it's not at all disallowed. Oh, okay. I understand now. Charlie was asking about why I am ping-ponging and double buffering instead of just reading and writing to a single buffer. So it would be fully possible to do it that way, but the real problem is synchronization. Like when you dispatch. So since if I have 1,024 particles and I'm dispatching correspondingly 1,024 threads to update the particles, like first of all, they're going to be running concurrently on different cores. So if I want some of them to update their positions, but all of them to depend on their previous positions, I have to either do the double buffering or use some kind of synchronization to prevent actually writing the new positions until everybody has read in their old positions. I think using the execution model of compute shaders, it's actually impossible to fully do that because suppose you only have enough cores to launch 512 of the threads, then you can't have them wait till the next 512 read out their data that they need before writing their data, because they're not going to be spawned until those threads have finished. So if you have like a global dependency like that, then you can make cores block on each other, or like use atomics, and spin locks are not really a good idea, but you can like use multiple stages, like relaunch the kernel to lock things. There are strategies for doing synchronization like that, but long story short, in a single kernel invocation, you can't have one of the kernels depend on another kernel. I mean, one of the threads depend on another thread, if it might not even be executed until the first one's finished, because there aren't enough cores to execute all of them. Okay. Another question, when you draw a frame with 1,024 cores, does it actually only tick 1,024 pixels, or does rendering the frame run batches? It does batches. Yeah, like when you look at when you're playing with Shader Toy and you just get a fragment shader, then it feels like it's just literally running a single thread for every pixel in parallel. But there are many fewer threads than pixels. Like there's basically enough threads to do like one row of the screen, really, one scanline at a time, about. And on a beefier GPU, there would be more, but I still don't think even the beefiest GPUs can run every single pixel on a 1080p screen at a time. So yeah, it will be running in batches, like streaming through the pixels. And they're not even necessarily synchronized batches. Like you kick them off, and then the longer pixels are still running while the shorter pixels are done, and then more of them get spawned once more cores are free. So yeah, it's like a pretty complicated scheduling thing, which is which is like kind of the main benefit of not doing things in compute shaders and using traditional rasterization is really scheduling. Like drawing triangles to the screen is really a scheduling problem, because you have one thread per vertex, and then all of a sudden, depending on the data that those vertices came out as, you have a very variable number of threads per, like for the number of pixels. So you have like work queues and like popping off work from the queues. Someone who actually works on GPU drivers would have a lot more interesting things to say, probably think I sound silly, but anyway. So I need to declare my buffer. If I do layout SCD 430 binding equals binding index, okay, let me start off. Is it a uniform? I'm going to find an example. Okay, it's not a uniform, I guess, but it's binding equals 0, buffer particles. Oh, and then pixel buffer is, I think, the struct. I'm a little confused as to what the variable name is versus the like struct name. Well, I'll see what goes wrong when I try to run the shader, I guess. Let me see if I can do, yeah, up to. So the shader compiled anyway. So how do I bind it? Oh yeah, so I guess an SSBO is like a single struct, and then it can have arrays of variable size in it. That makes sense. So my, yeah, positions is my variable. I want like a full example that actually uses it. Okay, yeah, so you can just refer to this as the variable. Okay, so I'm gonna make sure I have 1024. Let me just have a constant. That's my number of particles. And then in this case, I'm gonna have that. And then when I spawn my compute shader, dispatch compute, I'm gonna give it num particles. And then that will let me use my global invocation ID as the index into this positions array. Okay. So I'm not doing this for loop or the noise anymore. I haven't even put this in version control, so I think I'm gonna just add everything I have just so that I don't lose last stream's work. Alright, so now I feel free to delete all this. So I have global invocation id.x, and that's going to be my array index. So, and we'll see what goes wrong, but I can just do I can just round it off to an integer and then do an atomic add. So let's see what happens. So I guess there's a hard limit of 4 billion threads in a compute shader. Elliot, welcome to the stream. Okay, so it actually looks like we're doing something right, because let me bust out my magnifier again. You can see in the upper left the 0, 0 pixel is lit. It is fully white because it's the integer value of 1024, and if you remember from last week, my fragment shader is dividing by 100, so that means I'm feeding it a value well over 1 as the alpha. So anyway, I might have still messed up something with my like buffer format. Like, I'm not sure if it's actually reading in the vec2 correctly, but gonna fill this up with non-zeros with just like some random positions to see if it works. Okay, so let me just do and I'm doing this in like a sloppy, untyped way. Eventually I probably want to actually have this as a point struct with two components to it, but I'm just having x and y next to each other in the buffer for now. So manually implementing struct fields out of array indices. Okay, so why did I do that? So this is my x and this is my y. I'm just going to generate 2 random numbers. I already have... Did I pull in rand crate? Okay. Pull in rand crate, and then just have an example. Getting started, I just want a random float from 0 to 1 would be good for now. Okay, so it's rand prelude random. Let me see what kind of values this gives. So let me just print them all out and see what happens. Of course, it needs to be mutable. Okay, so it's giving us values 0 to 1, which is what we want, and then I can just multiply these by 800 and 600. Again, hard coding some constants in. So it looks like it is not working because it's still my upper left pixel, so the shader is still getting... I mean, that makes sense. I actually forgot to ever bind the SSBO, so I think it's just reading zeroed memory and getting zeros out. So looking up an example. Find the storage index. Okay, so yeah, this is like with uniforms, getting the storage block index, and then we want to bind it. Yeah, so if I just hard code the binding, I don't need to look it up. Binding equals 0. So shader storage block binding. After I use program over here, before I dispatch compute, I need to... So let me look up the docs for that. Hey, Soham. Okay. So program block index block binding. So I think that would be, my program is comp.id. My buffer is particle buffer. And then my binding point, I just declared as 0. So that should be right. Let me see if this works. Did not work. Alright. Missing something. Okay, I can use Swan now. Yeah. For sure. Who is Tiny Pillow? I don't think I know who that is. Okay. Let me go back to the example because I'm probably missing something. So wait, I think block index is... What is the difference between block index and binding point index? Let me just do it this way. Okay. Promise I will extract some of this into other functions eventually. Get program resource index. Hey, it's Huel. Twitch money. I have no clue. I have never given or received Twitch money before, so... Okay, so I need to find the storage block index, program shader storage block, and then the name, which in this case means a manually written null terminated string. And then shader storage block. So I'm block index. Oh, it returns it. Okay. I'm used to having to pass a pointer, an out pointer. Wait. Yeah, so I assume that this works with bind buffer, so I need to use block index, and then I still have my buffer bound from up here. I may as well. Okay, let's see if it works, and then I might need to put another bind buffer after the use program. Okay, it did not work still. Oh yeah, okay, so yeah, chat seems to think I need to get partnered to get Twitch money, which I need to go check. I think I need like 50 followers or something, and I think I'm already over the average viewers per stream for affiliate, but I am not affiliate. So what is happening in chat? Okay. Gonna try to get things actually working. Again, it's taken me 40 minutes to get the basic OpenGL stuff working. Okay, and then I need bind buffer base. I'm reading chat too much and getting confused. Okay, 3 average viewers, 50 follows, and some amount of hours live in a period. Okay. Yeah, it's pretty low. It's a lot more achievable than I thought. Okay. I'm just going to start back from the beginning of this example. So I have my layout buffer. In my case, it's particles. They have some vectors, so that will be helpful for me to compare. I have a vec2 positions. Yeah, uniform is replaced by the buffer keyword. That makes sense. Find the storage block index. So I'm doing that. I'm doing get program resource index for, but it should be particles, not image. So now I have block images, block indexes for particles, and then I pass block index to shader storage block binding. My binding point index. Oh, this is what I don't need because you can just write binding. Yeah, okay. Reading, catching up on chat. Swan's computer is in French now. Okay, so yeah, shader storage block binding 0. I think that should be sufficient because I'm declaring it a 0 in the shader itself. Finally, I need bind buffer base with shader storage buffer, the binding point index, and the actual SSBO object. Okay, so it's not bind buffer, it's bind buffer base. Bind buffer base, and then it takes binding point index is 0, and then the SSBO is called particle buffer. I'm gonna read through to this before jumping the gun and trying to run it again. Pour conclude the article, here are some. I think that's everything. So it should work now. So I have now replaced. It's reading stuff that isn't 0 now because there's no white pixel in the upper left corner now. But I don't see any white pixels anywhere else. But maybe I should not divide by 10 by 100. I should divide by 10 instead, or maybe just 1, so that I see anything. They might just be too faint to see. Yep, they were. It's working. Okay, so here I'm generating 1024 x and y positions. I'm reading them as vec2s in my shader. And then I am writing out to the shader. Writing out to the texture just at that position. And I've generated them between 800 and 600, which is the size of the image. So yeah, success on our first step. This looks like where I was at about an hour in last week, but last week I was generating the positions in the compute shader, and this time I'm passing them in a buffer, which lets me eventually use that buffer. Okay, so yeah, for those who were not here at the beginning of the stream, so what I'm trying to accomplish here is I have a texture that I use a compute shader to write a bunch of values into, and then I have a regular fragment shader that I use to draw a rectangle to the screen just of that texture. And what I want to happen is that compute shader should be reading from a buffer which contains particle positions, and then every frame I'm going to be using another compute shader to move those particle positions around. So yeah, Boids. Yeah, each of those points is a small animal. Boid it's not just an I dialect for bird. It's actually short for birdoid, like bird-like thing. Which is, I think, comes from this paper that I had open at the beginning. I think they coined Boid in here. Yeah. Let me see. Birdoid. Oh, okay, they don't have the string birdoid in here. Well, maybe it predates this paper, but in any case. So next thing I need to do. Yeah, this is actually Craig Reynolds. So yeah, Swan just posted in chat. Boids is developed by Craig Reynolds. This is his paper about that program, actually. He's also got this excellent Web 1.0 page with more details about it that I'll probably be looking at more closely once I'm trying to actually implement this. So next thing I need to do, now that I have my particle buffer, I'm going to make another compute shader for updating particle positions. So let me rename this to be not just comp, but I'll call it draw. Yeah, I will post these links somewhere after this. Okay, so I renamed it to draw. I'm also going to rename the file to draw. Yeah, draw.gls. And then I can have a new compute shader called update. And then like I said last week, I've been spending the past 6 months talking much less than usual. So my voice gets hoarse after like 45 minutes of talking. Okay, let me make my my update program from update.glsl, and then I'm just gonna, so we don't need the image in here. Oh, wrong shader. So we don't need the image, but we do need the particles, and we're actually going to make a second buffer for the outputs. And we'll be flipping those back and forth, like I explained. So particles in, you can only have one dynamically sized buffer, I think, per shader storage buffer object. So I think I'm gonna make a second one. Hey, it's Zianic. Thanks for joining. Maybe I'll sing in the shower more. Okay, so particles out. Now I have my two. I think I need to name these differently also. So positions in and positions out. So let me just copy paste my buffer code, which I promise I will put into a function after I get this working. So let's just call these 1 and 2. And then I'm going to make a second one. No, I'll deal with that later. Okay, so particle buffer 2. And then I'm just gonna initialize particle buffer 2 with, it doesn't matter, I'll just initialize it with the same data because it's gonna get overwritten after the first dispatch. So okay, I have my second particle buffer. So my first program update has two buffers, buffer objects. So I need to do this twice after I use program. Okay, so oh, I just got my shift scroll for my left and right. Soft wrapping I think messes me up worse because it like, I don't know, I'm just not used to looking at it. Oh, do you need me to explain? Does chat need me to explain like the basic concept of a shader? So okay, so basically to start with the basics, the way that I always like to explain this is by rewinding to before there were shaders, what graphics APIs let you do. Yeah, I can just start from the basics. So in like the early 90s, there was the OpenGL API, which is what I'm using, but basically none of the functions I'm calling were in it at the time. What it let you do was you would like you would call functions like begin triangles and then call a function to specify each vertex of the triangles, and then you would you would draw the triangles to screen, and you would have a function to specify what color each vertex was, and like have a function to specify if you use textures, you would tell it this is a texture coordinate on each vertex. So it would basically be like you didn't write any shaders, you just called functions to feed it data every frame for a bunch of triangles, and maybe with textures on them, maybe with colors on them, and then it also had kind of a fixed template for a lighting system where you could say like there's a point light here, a directional light here, and then so you couldn't write the actual lighting equations, you could just specify the colors of the lighting and the normals of each vertex, and then OpenGL would direct the GPU to perform those calculations for you. So you had very little control, but you could do basic 3D rendering. I wish I had some like good screenshots. Yep, yeah, every single frame you would call the draw triangle function, and it would like, I assume it didn't even have like resident memory on the early GPUs enough to like store the whole mesh at a time, because I assume it was just streaming them over every frame and like maybe batching up a few vertices. But I mean, GPUs have increased in parallelism. I think early GPUs were more like streaming processors that just like churn through a lot of stuff in a row. Okay, so yeah, Lewis, who was actually there back in the day and like has experience with a lot of this stuff, I defer to him about this kind of topic. But anyway, he points out that they had display lists from pretty early on, which basically lets you, if you make all those like 1,000 triangle calls per frame, you can tell the API, this stretch of my program, basically record that as a display list and then redo it every frame. So it could like save those triangles, cache them between frames. But yeah, anyway, long story short, it's sort of analogous to like how the HTML5 canvas API is like just a bunch of kind of fixed functions that you call for drawing lines and paths. You didn't get you can like write a function for computing a gradient, things like that. So we have this fixed pipeline. I'm gonna pull up a nice pipeline diagram. I think there's one on the OpenGL wiki. So rendering pipeline overview. Yeah, so here we go. We have all these stages. So not all of these stages were there, but you would specify your vertices with all of those triangle calls or whatever. You would specify a transformation matrix for taking the vertices in 3D space onto the screen through a couple of stages, from like local model space to global world space to camera space, and then to a projection transform. And you didn't write a program for that. You just gave OpenGL a 4D matrix defining a projective transform. And then primitive assembly is where the transformed vertices get turned into triangles. Rasterization is where triangles get turned into sets of pixels that belong to the triangles. And then again, I explained how you can specify colors, texture coordinates, and lighting equations. But you wouldn't write a program for this stage. You would just let OpenGL do those lighting calculations for you. So most of this pipeline existed, but none of it was programmable. So basically the two stages that were initially programmable were the vertex shader and the fragment shader. So, and those are the parts which in the fixed function pipeline is what it's called before you could write shaders. You would write, the vertex shader is just a matrix multiply. So now you can write your own program that maybe instead of just doing a matrix multiply, it will like use a sine wave to displace ocean vertices. So like that's a simple example. And then fragment shader, you get to write your own lighting equations. You get to do like different models of diffuse lighting and things like that. So yeah. So a shader is just like a simple, basically purely functional program that transforms either one vertex or one pixel. So it's like implicitly parallel. You write what happens to one of those, and then the GPU and the graphics driver are responsible for scheduling them. So yeah, there are many more shader types nowadays. There are tessellation shaders, which actually consist of 3 separate shader types. There's hull and domain and another one, and then there's geometry shaders. There are also mesh shaders, which are relatively new. The ray tracing hardware introduces like 3 new ray tracing related shader types. Okay, question is why one game looks... Basically, yeah. in the fixed function days, everything looked roughly like an N64 game, right? Like you could basically do what you could do in Mario 64, you know? Yeah, Doom actually predates GPUs. Doom was just software rendered, like that's just a program running on the CPU. So actually the way Doom is written, you get a lot more freedom because it's your own code running on the CPU. None of this is like fixed hardware. So on the other hand, you're constrained by like it's really slow, so you don't have like specialized circuits to do all the hard tasks for you. But on the other hand, you have a lot of freedom over every little bit. Fixed function pipeline graphics basically like um, game consoles are all work that way up until like I think I would say like PS3 era is when it started to be really programmable in this way. And before that, it was like fairly fixed like this. Writing your own soft float library. Basically, yeah, it's a similar thing like that. Yeah. So okay, where was I? So there are a bunch of new shader types. The final one that I didn't mention yet is called a compute shader, which is really an oxymoron because it's named that because it's a shader that doesn't do shading. It does arbitrary computation. And it runs in the same scheduling paradigm as the vertex and fragment shaders, as in it gets scheduled for you. Like, okay, so I wrote my draw shader. So you can see I have my main function and I'm looking up one position in my positions array, and then I'm doing one atomic add into my image buffer, but you don't see one, oh shoot, it's not in a compilable state, but you remember it had all the points. So this is obviously not just being run once, it's being run 1024 times. And the place that I specified that was, I call this dispatch function, GL dispatch compute, and I pass it exactly how many threads of this compute shader I want to run at the same time. So is that like a good answer to the question, what is a shader? If I had like planned out that explanation a bit more, I think I could have done a better job, but okay, cool, yeah. So anyway, so I'm trying to do as much as possible in compute because I want to get more experience with it. Compute shaders they kind of depart from the pure functional model. I mean, like I'm already doing something that's not purely functional. I'm statefully writing into an image buffer. And really if you want to do things in like a super performant way, you have to depart from the pure functional model. Like, for instance, if you want to do a sorting algorithm or a scan, like a parallel scan across an array, you technically can do that purely functionally using just a pixel shader, and people used to do that before compute shaders were available. But it can, because of the fact that you can't share state or like really factor redundant computations out of multiple of those threads, like they can't cooperate really, you're forced to write like n squared complexity, like if you know I don't know how many people are familiar with the Schlemiel the painter story. So I learned this from famous tech blogger Joel Spolsky. But anyway, the Schlemiel the painter story is, so Schlemiel the painter, he gets a job painting the lines in the middle of the street, and so they give him his paintbrush and his paint bucket, and he paints like 350 feet the first day, and then the boss says, great job, keep it up. The next day he paints only 400 feet. The boss says, well, that was still pretty good, but not nearly as good. No, sorry, he only paints 50 more feet. And then the third day he only gets like 2 more feet. And the boss is like, what's going on, Amar? Are you painting so much worse than you were the first day? And he says, every day I get further and further from the paint can. So basically he is unable to meaningfully reuse the work from day to day because he's repainting from the origin every time. And that's a similar situation to a lot of algorithms if you try to do them in that purely functional, like parallelized way. Because a sorting algorithm, there are parts of it, like most of it is inherently sequential. Like you can parallelize parts of it. And a sorting network is like basically shows which parts you can do in parallel and not. But it's not all of it. You could technically have a purely functional shader do a parallelized sorting algorithm, but inside each different thread, you would just have to be sequentially doing a bunch of wasted work. Compute shaders let you use shared state and mutable writing operations to memory, and using atomics to cooperate between different threads. So it lets you write much more efficient algorithms for things that are of weirder shapes than just drawing a bunch of pixels to the screen. It also means it's easier to mess up really bad, more complicated. There's crazy stuff that you can do because not only are there a bunch of threads, but there are 2 levels of hierarchy that the threads are executing in. So if you have 1024 threads, if I were to declare this is my local group size. If I were to say 64, then that would tell it to schedule my 1024 threads, make sure that I have 64 thread groups, and those get kind of access to like a faster shared memory that only they can use, so they can cooperate in that shared memory. And then below that level even, the secret is that this is not just being executed sequentially on a single core. The cores are all SIMD cores, so like some number, like ranging from 8 to 64 depending on the GPU architecture. These are not just being run on separate cores in parallel. It's like every instruction of this is in lockstep being executed in SIMD for n different threads at a time. So there are operations you can use to pass information between those threads with basically like zero overhead. Like if you're using atomics, that has to at least like take a round trip to local or global memory, which is not free at all, versus if you're executing on a single core, like 8 threads together, they can basically do completely free synchronization and just shuffle around values between those. And that's when it gets like pretty galaxy brain. I haven't played with any of that, but it's pretty cool. Okay, back to what I was doing. So I have my update shader. It takes in a buffer. It has another buffer it's going to write out the results to. So update is not going to do an image add. It's going to get its previous position, and then I'm going to take positions out, and I think I'm just going to have it add one to each of the coordinates. So I'm just going to see, I'm not going to try to run this yet. I'm just going to see if the shader compiles. Well, if the Rust compiles in the first place. Yeah, it gets really crazy. So probably the craziest thing I have seen with regard to compute shader acrobatics is there's a vector graphics library called Spinel, and it's so here's it's part of the Fuchsia umbrella at Google. Like it lives under that repo. I don't know exactly if they use it in practice, like how they do or whatever, but it's under the umbrella. So this is one of the compute shaders. I mean, it's 2,200 lines long. It's using, this is what I was talking about with those intrinsics where you can have free synchronization between different threads executing on the same SIMD core. Subgroup shuffle, it's using them all over the place. And if you look, there are all these comments about like NVIDIA architecture works like this. So on NVIDIA architecture, we're going to use this method and so on. And it's just like, it's galactic. It's way too much for me. I don't think I ever intend to write compute shaders like this. It's just too much for me. I prefer to stick with kind of a more portable subset of the things you can do. Just because like I'm only gonna be on this earth for so many years, but anyway. Yeah, there's some pretty crazy stuff out there. Okay, so I have my update program. Why is it not compiling? Who's Agnerfog? Let me Google that. x86 Galaxy Brain guy. Basically, yeah. Yeah. Okay. Line 63. I renamed the shader, but oh, I'm stupid. Here we go. Copy pasted it and didn't rename it. Particles in. Okay, so where did I declare write only bind image texture? I'm not sure if there's like an equivalent for shader storage binding. Particle buffer. Yeah. Okay, so down here I'm just going to use particle buffer 1. I'll have to keep track of which one is the latest one eventually after I'm doing the double buffering, but for now, I'm just going to use the first one. Yeah, it's, there's a lot to know, and it's not all in one place. Like, there's pretty good documentation out of the hardware companies themselves, like big, huge PDFs you can read about their architectures. So you can learn it if you want to, but like, it's just a huge quantity of information. Like, compared to some of the things you need to know, just the fact that you can't use if statements of a certain type or for statements of a certain type in like before the year 2007 or whatever is like a relatively easy fact to remember. But yeah, like the types of there are driver bugs that you'll run into where it's like miscompilations happen on only one vendor because up until recently vendors took graphics drivers took shaders as string inputs. I mean, they still are for me right now. Like OpenGL does it that way. The more modern way is to have like an intermediate bytecode. Whether it's like derived from LLVM bytecode or it's SPIR-V is the one that Vulkan uses. I mean, even then you get miscompilations, but like literally there are differences in parsing and scope rules between different GPU vendors. Like I had a problem where I was naming a variable max or min, I think, but because that's a built-in function, it was, I think on NVIDIA it was erroring, but on my Intel GPU it was doing just fine. So like that, like literally the semantics of GLSL subtly differ between different vendors' drivers. Fuchsia, I know that Rafe Levine was at least working adjacent to the Fuchsia people at Google. And he does text input stuff. He worked on the Android font rendering stuff, so maybe it's different. It's probably not the same guy. But yeah, ligatures get pretty. Wait, there's also the guy who made Harfbuzz. I'm forgetting his name. Who did Harfbuzz? It's Behrad Esfahbad, yeah, he is also has dug into the deep hole of ligatures and font shaping. It's a pretty deep hole. Okay. Yeah, that's who you're thinking of? Okay, yeah, he's a pretty cool guy. He's like he basically like works on his permissive license open source library and then just wanders between big tech companies, seeing who will pay him the most to work on it as like a public service, basically. I wouldn't say that you have to know at an LLVM backend writer level. I would say that that's if you're literally working on graphics drivers, like if you work at Intel or AMD or NVIDIA, and you're working on drivers for the hardware, you need to know it at the level of an LLVM backend writer. AAA devs, I mean, often a game is simultaneously targeting all of those, and you can't dive so deep into one because you need it to run well on all of them. You do need to know like high level stuff, but it's more like the level that CPU programmers need to know x86, like not at the level of a compiler engineer. Oh, I didn't see that. I saw some stuff about Iran that he was tweeting about, but I didn't see the PR that couldn't be merged. That's crazy. Okay. It's compiling now. Spent a long time talking and not coding. We're not actually running update. So we're creating our two buffers. And then after we do use program, we're going to bind buffer 1, bind buffer 2, 2 particles out. Yeah, he had a pretty crazy story. And then it's going to be layout 1, binding equals 1, particle buffer 2. And then now that I have bound my buffers, I can do GL dispatch compute. I've already called use program, and I do want num particles as my number of threads. Okay, so it's doing nothing like I thought. I'm going to make the draw shader draw from particle buffer 2, and then I'm just going to do something drastic here, like update it by 100 pixels, and we should see everything move down, like we should see a gap in the upper left. We don't, so something's wrong. Maybe I need to actually use a function to be writing to it. I need to read more on SSBOs. Okay, so there are atomic operations. Maybe I need a memory barrier. That does sound right. Oh, thank you. It's nice of you. Thanks, yeah. Aaron got me this shirt. So. Yeah, I think I might have to like try to collect my thoughts about what shaders are in like text form and put it up eventually. I do want to do eventually like more focused kind of teaching streams, like I want to do a lot of like 2D graphics basics teaching, like for algorithms for drawing lines and stuff, and then like anti-aliasing and then collect that into a book. But yeah, I think I might have to do it with like kind of the fundamentals of graphics programming on GPUs as well. Okay. So I need to insert a barrier like I have here, but it's not the shader image access, it's the, after I've done dispatch compute, I need, okay, so GL memory barrier. it can, the possible flags it can take are bitwise combination of vertex attribute, element array, uniform barrier, texture fetch, shader image, command barrier, pixel buffer, shader storage. I still am not sure if I'm allowed to just be setting it like this, just like using the equals, because for an image, you have to use the image store and image load functions. But then again, I can just use array indexing, so like presumably I can just do that. Okay, so I'm using dispatch compute, and then it's the shader storage barrier. Still not working. I'm gonna just like make it even more drastic just to make sure. So I should be drawing from particle buffer 2. Yeah, I'm finding particle buffer 2 for my drawing one. Let's just make sure that's not the problem. So I'm doing a memory barrier, so it's not that it's not synchronized. And I would kind of expect, like, actually I don't know what I would expect. I don't have any experience with like what happens when you don't use memory barriers and then access the same resources. Probably some cool glitch art as a result. So I'm using particle buffer 2, which is what I'm writing to. Do I need to have it bound in some kind of read-write instead of just read-only? So, like bind to buffer base. Okay. SSBOs are writable. Maybe I need a memory qualifier. I don't have read-only or write-only, so I assume... Apparently you can have both write-only and read-only on an image. Which I guess means you can't do either, but you can look up attributes of it. Okay, I'm going to look up... this is kind of a... this is a sort of a different notion than like memory barrier at the instruction like intrinsic level, because there is a way to use memory barriers in GLSL shaders themselves to like do synchronization like between this statement and this statement. But this is like a OpenGL API level memory barrier, so it's like all of these threads that I've just dispatched, wait till they're all finished writing to this resource before letting me continue. So it's kind of like a larger scale memory barrier. So I need to have an example of writing to an SSBO. I think this one might do it. Nope. This example that I had open. Do they have like the full source? Okay, I'll look somewhere else. Yeah, it would have to be implemented with like a... I mean, the OpenGL driver is like single-threaded, so from the CPU side, it's kind of just like... It's just like a question of how it implements scheduling. With Vulkan, it's actually multi-threaded, so it would entail CPU side synchronization as well as synchronization with between CPU and GPU. But yeah, okay. Maybe this has an example. Not helping me. Yeah, so they're doing what I'm doing, just like writing to it. Also says it's not working. Okay, I actually don't know what the difference between a fence sync and a memory barrier is. I mean, I assume it's just like execution versus the resource usage. Okay, yeah, they're saying that the memory barrier is what you need. I do already have one, so not actually sure what the deal is. But yeah, my memory barrier should be making the memory access synchronized so it's not undefined or anything. Maybe the buffer storage needs to have... Okay. Shader storage buffer. Yeah. Read-write storage for shaders. Maybe I need to call this the buffer storage thing to specify it as write bit. Yeah, it might just like not be writable. So when I create the buffer and do buffer data, maybe buffer data has these same flags. Let me check. No, it just takes these. Okay, so yeah, let me call buffer storage with data. Yeah, this is, I think, what I need. So if I give it shader storage buffer as the type, so I still pass it shader storage buffer, and then I pass it the size like I'm doing, and then I pass it the pointer, but it's a flags instead of just the storage hint. Wait, this is all for whether the CPU side can write or read from it. Only the first element of my array gets updated. This is horribly formatted. I think it's probably scraped from somewhere else. I am so confused. Let's make a use shader storage. Oh, sorry. GL buffer storage, yeah. And then we need to pass it. Let me look back at the SSBO. They have. Maybe I will do write only. I'm not sure where you put the keyword. Coherent qualifier. Okay, it's right before buffer. So let's say write only and read only before these, just to see if it helps. Okay, so not what we expected, but the upper left pixel is white again, which means all of the positions are 0. That's very confusing to me. I'm going to change these calls to buffer storage back to buffer data, just to make sure that's not what I messed it up as. Okay, so it's just not working. It's still just not changing the data. Yeah, and I made the second buffer be full of zeros, and now their positions are all 0. So yeah, it's just not updating them. None of the Stack Overflow questions have helped me. SSBO write not working. That's my problem. Buffer data should be yeah, to be honest, okay, so actually, here's a story about how I am dumb. Last week, I was trying to use RenderDoc, which is a graphics debugger, and it wouldn't work. The reason it wouldn't work is I was just entirely missing a swap buffers call, which is supposed to be just what makes anything go onto the screen in the first place. It was all going onto the screen anyway, I guess because after enough frames, it was like flushing the commands and doing it anyway. So it was working when I ran my program, but RenderDoc looks for the swap buffers call for when to like delineate frames. Oh yeah, Hubble at end of stream is gonna happen every week. I hope it looks cool in turquoise. Okay, let me see if RenderDoc can tell us anything interesting about this compute shader state, because I actually got it working by putting what should have been there all along, that swap buffers call. So compute, where is it? There it is. Target, release, compute. Okay. And because I'm not actually doing this every frame, I need to queue a capture on the first frame. So now I have a capture. Oh, I don't remember the story. Okay, so yeah, here we can see, this is very nice. I can see both of my compute dispatches and then my draw elements. Just in the spirit of teaching how graphics work, let me show because this is cool. So my draw elements, RenderDoc lets me look at the rectangle, which is made of two triangles that I use to draw the texture to the screen. And the input texture, you can see, I think it has that one white pixel. Maybe not, but it might not be displaying correctly. Then the outputs is the actual screen with that one white pixel. Okay. So I wonder if it has anything in the pipeline state. Compute shader. Yeah, this is kind of funny. So like, there's the whole graphics pipeline. All of these types of shaders run in order. And then next to it is just, there's also compute shaders. Okay, so it says there's no resource for particles out. That makes sense. I mean, that makes sense why it wouldn't be working. So there's no resource allocated in the first place. So let me look back to where I'm allocating particles to. Particle buffer to, oh, sorry, yeah. I'm doing gen buffers. This, I could actually use gen buffers too. So all of the gen functions for creating resources in OpenGL take a count and an out pointer, so that if you want 2 of them or n of them, they can be written into the array at this location. And I've never used that before, but I could actually use it right now. Okay, so I'm binding the buffer, particle buffer 2. I'm doing buffer data zeros. So why is there no resource? Oh, the story about called every color blue. That's cute. Yeah. Okay. No resource. Access is read write, which sounds like it's what it's supposed to be. I'll just leave this open. Let me undo my most recent change, because that may be the cause. Rebuild, and then launch application again. Here's my new capture. Pipeline state, no resource. So yeah. Well, what's interesting is, okay, particles in, which in my code is buffer 1, is buffer 47 as in like the resources. But then my second compute shader, I'm binding particles 2, and that says it's also buffer 47. I'm sure I'm doing something just dumb. I wouldn't say it's necessarily the standard one. I would say if you, because, I mean, I would say it's the most cross-platform one. It's like probably the most broadly applicable one. There's an Intel specific tool, there's an NVIDIA specific tool, I'm pretty sure there's an AMD specific tool, and then all of the game consoles have like console specific tools, and then Apple has some Metal tools, and Microsoft has some DirectX tools. RenderDoc is free. I'm pretty sure it's open. Yeah, it's open source, and it works with a wide set of those things. Like it works with Vulkan, OpenGL, DirectX. I don't know if it works on Metal, but yeah, and it's the free one that is not like specific to a particular vendor. So yeah, it's like kind of the default. I wouldn't say it's always harder on Linux. I would say working with DirectX on Windows is like the most blessed way to do graphics dev, because that's the largest market for 3D games. So that's like what drives new graphics hardware. Like that is coexisting with like machine learning and compute applications nowadays, obviously, but like for a long time the big advances in graphics hardware were motivated by 3D gaming on Windows with DirectX. So in some ways, I've never actually done a lot of stuff with DirectX on Windows, but from everything I've heard, it's like the least janky experience to have. But on the other hand, I think that Vulkan probably is better supported on Linux than Windows or Mac. Like, you can't use it on Mac unless you have a translation layer to Metal, and Windows supports it, but I don't know if it's the best support. On the other hand, the driver situation is horrible on Linux. Oh yeah, okay, so what are Vulkan, OpenGL, DirectX? So they're different graphics APIs. So it's just like there's a piece of GPU hardware somehow connected to your CPU, whether that's an external one or it's on chip, like with the. I mean, it's on board like the Intel ones. They come bundled with a GPU on the same motherboard. And you need to be able to communicate with it. So it's got like an instruction set architecture, obviously. And then you've got a driver for controlling it, uploading data, reading back data, launching code, and so on. And then you've got a compiler for that particular instruction set. And then you have, on top of that, various standard APIs that are cross-platform. I mean, I would say DirectX is cross-platform in the sense that it works with different companies' GPUs, even if it's only works on the Windows platform. So yeah, DirectX is just the one Microsoft makes for Windows. OpenGL is an open standard that is supported to some degree on Mac, Windows, and Linux. This code that I'm writing right now would not run on Mac because they don't support the newest versions of OpenGL. They've technically deprecated OpenGL. I'm hoping they let it continue working for a long time. And then Metal is basically Apple's like answer to DirectX. It's their own proprietary one. And then Vulkan it's like an open standard organized by the same people as OpenGL, but it's like the next one. It's a lot more low level and complex to use. It's a lot less friendly, which is why I didn't decide to do that on stream, because I'm already having enough trouble just like running a compute shader right now. But so yeah. And Vulkan takes SPIR-V, which I mentioned earlier, which is it's a bytecode format. DirectX takes a shading language called HLSL, but it also can take a precompiled version of HLSL, like a bytecode format. Metal has their own shading language called Metal Shading Language, which is fairly different from the others and like more C++ like. The others are like GLSL is closest to kind of like a memory safe C kind of. But yeah, so GLSL is the only one that takes GLSL. I mean, OpenGL is the only one that takes GLSL directly. But there are cross compilers. Like you can, like for instance, Unity has its own shading language that it compiles to all of those. Unreal uses HLSL and cross compiles that to the other ones. So, yeah. What did I do? Why did this happen? Oh, I think it's because it's because I have it open. Dumb mistake. So the weird thing was that particle buffer 2, particles in, particles out. Let's just name these different things. 0, 1, and then they have different bindings in the shader. I'm calling use program. And I'm binding the buffers in turn. And I'm calling buffer data. Okay, I'm gonna do renderdoc again. So, first compute shader, pipeline state, particles in is buffer 47. Is buffer 46 and 47. I assume buffer 46 is, okay, maybe I need to call bind buffer when I'm doing bind buffer base. Yeah, maybe I need to do bind buffer for particle buffer 1 down here. This is just, I'm not sure if this is what I actually need to do, but kind of spray and pray approach. Okay. And then down here again. Let's see if the pipeline state thing changed. Still no resource, and it's still buffer 47. So that was not the problem. Yeah, I'm confused. Yeah, I really should set up better error detection stuff, because like when I'm working on this on my own, it still would be worth the time to do it, but it's only my time that I'm wasting. But now I'm like wasting time on stream, and it feels worse. So I really should like get my error handling straight. Okay, let me go back to an example. Bind buffer base takes the SSPO as its third parameter. Okay, I'm just going to read through this example. So they create the shader, they fill the buffer, they make an SSPO, gen buffers, bind buffer, buffer data, then they unbind it, they do bind buffer base, dispatch compute, memory barrier, bind buffer base, bind buffer, map it in. Well, I already know I'm binding one of them properly, so this isn't really what I need. But yeah, I am drawing from particles to, Yeah, you're right about that. But I don't think that was the actual problem. Oh. I think this is the real problem. Okay. I think it might all be working. Yeah, okay. Lewis with the actual answer in chat. Let's make this just be 100. Yep, okay. Again, I have like the basic thing done an hour and 40 minutes into stream. But now I can pretty simply just start ping-ponging these buffers and use this to update it. And I can, it's possible for me to just, so my plan is just to write like a n-squared algorithm where every thread looks at every other particle and then updates the current particle. And I can do like tile binning or something later to accelerate it. But for now, I'm just going to do the naive n squared version. I don't think Bowsette is in Melee, no. Yeah, that's true. That's true. I spent a lot more time this week just like talking instead of working. So I don't think I wouldn't consider it a waste of time at all. Okay. So currently I'm just running the compute shader once and then drawing the frame once. I need to be drawing every frame. So I'm gonna ask for VSync here. And then I'm gonna start with VSync true. With VSync true, and then now I can. Okay, I'm doing something wrong. Okay, I need to not be swapping buffers out here. I need to be doing this drawing. So I actually am drawing every frame. I'm just not doing the compute shader every frame. I should only be doing this in the redraw requested. And yep, now it doesn't hang the inputs. Had this problem the other day. Okay. So yeah, now we want to move our compute shader stuff into here as well, so it's happening every frame. Which means I also need to be clearing the texture that I'm drawing to every frame, which should be pretty easy. It's just a texture, so I just clear it. Is there like a clear texture? I assume there would be, at least in the newer APIs. Yeah, clear text image. Okay, yeah, it's only in the new in OpenGL 4, but it does exist. Okay, so when I have the buffer bound, I can every frame. I swear I need to take some time to organize this code. So I'm gonna bind my image buffer. I think it's bind texture. Okay, where even is it? Bind image texture. Text image 2D. Oh, this just takes the texture. Yeah. So clear text image. And then the texture is called text. Level 0, only have one level. Format. One and 4 components of textile data. Filled with 0, so I can just pass null. Okay. Text 0. Format. Type data. Okay, so format. Let me just copy those from my text image 2D up here. Format is this. And then is that see like for example here I'm passing Like this is the same type of argument. Like it's a texture format. I cast it to an i32 because TextImage2D required an i32, but here apparently they want a u32, and like that's just in the actual OpenGL API and has been for years. Okay, so I'm clearing it every frame, which it's surprising me that it's working. Or I guess, okay, this is telling me that clearing it is not working. So it's not clearing it successfully. Or else it would be blank. Making me mad. Why is this working? Texture level format type data. Texture level format type data. Okay, I really just want the particles to be moving before giving up for the day. So if I'm clearing the image and then it's not showing up as cleared, that is very confusing to me. And I do have a memory barrier after the computer shader that draws to it. So I don't think that's the problem. Let me just throw one in for good measure. I mean, okay, so that doesn't actually make sense because this is happening every frame. So like, it should have been cleared at some point. It doesn't make any sense. Let me do get error. Let me see if this is erroring. It is erroring. I don't know if it's from that call or something else. Yep, it's from that call. 1280. Remind myself what that is. Invalid enum. No, it's not. Is it? .1280 is invalid enum. There are no invalid enum things on here. Let me just do it the dumb way and do TextImage2D with a blank array full of zeros. Yeah, let me just copy paste this again. So Okay, that worked, yeah. Giving up on that for now, just doing it this way. And then I need to call the draw. So this is okay, I've set up my... Okay, I am just going to copy paste everything into the per frame thing. I can leave this out. Yeah, this happens at the beginning. But this stuff... Okay, this happens once to generate the texture. But this needs to happen every frame. So let me just copy paste that in. Let me delete my timing stuff. Okay, so now it's working. I am clearing and then drawing to the shader every frame. Now what I need to do is be doing the updating every frame and then ping-ponging the buffers. So I think I'm just going to do that by like setting, like swapping particle buffer 1 and 2, the names of the buffers every frame. So I'll start out, I have my random particle positions in particle buffer 1, and then, so I've created my buffers, and then I've created my program. This is the thing that needs to happen every frame. So I'll put this before I use the draw compute shader. Doesn't need to be separate and safe block. So I'm using the update program, bind the buffers. And then after I do this, I'm going to swap the buffers. It's cute that I just call swap to swap the buffers. Anyway, now this one will use particle buffer 1 instead. That makes sense. They are flying off the screen instantly, I think. I might have messed something up. But let's just make it do nothing and see if it still works fine. Okay, I messed something up. So what am I messing up? Every frame I am reading from particle buffer 1, writing to particle buffer 2, then swapping those two variables, and then using particle buffer 1 to draw from. I have my memory barrier, so it should be fine there. Let me render doc again, see if something's like not bound properly. Oops. Pipeline state. Yeah, I can look. Okay, this is cool. I can look at my actual buffer contents. Extremely useful. But this is the first frame, so let me not queue the first frame and just capture a later frame. It's not working. Oh, I think it's because it's not requesting redraws very often. So maybe let me just call request redraw. Okay, let me just see if it's actually happening repeatedly. I don't know why it's not happening more. I'm using a newer version of gluten than I usually am. Okay, this gets triggered in two scenarios. The application is called request redraw. The OS has performed an operation that invalidated it. Okay, maybe I shouldn't use this for a game in the first place, or like a real-time thing. Also, let me try doing this after handling events. I move my mouse, and it happens. Okay, in any case, I think I can trigger a capture. Yep, okay, got one. So, let me look at my buffers. So this one takes this buffer as input. Am I not calling use program or something? I am. Oh, you know what? Okay, this is embarrassing. I have two programs called draw, and I'm overwriting one. That's very silly. Okay. Let's just call this one quad instead. And then this one called quad, and then where do I have my use program? Yep, this should just be with, that was just missing. Okay, crossing our fingers, this is the one. So at least I'm calling the right shaders. Let me look at my particles that I'm passing, my positions. So it's drawing some real positions. These should be showing up on the screen. Yeah, so so the problem is not the actual data in the buffers, because that all looks good. The problem is something else. Clear color. Wait, let me look in RenderDoc again. So what is the output to the image texture? Okay, so it is outputting correctly. I think it's just not drawing. I messed that up somehow. So active texture, texture 0, bind texture, use program. Okay, one more thing in RenderDoc that I should have looked at is the actual draw of the quad. Texture viewer, its inputs are correct. Its mesh is looking correct, yeah. But its pipeline state, that is weird. Yeah, it's getting the correct input, and then we're not seeing it. I'm calling draw elements. Okay, that's the problem. I think I'm not rebinding the vertex arrays, yeah. So it's just drawing a blank zeros quad. So that should be fixed now. It's not fixed. Gen vertex arrays, bind vertex array, gen buffers. Oh, forgot. More dumb renaming mistakes. This one should fix it finally. There we go. I'm assuming I want this to not be running on every input event, but at a regular interval. I'm sure there's an example where they do that. I guess they don't have any examples. Oh, here's examples. Okay. Oh, I'll just leave it for now. So update needs to actually do something. Hopefully they slide down the screen this time. They do, yeah. It only happens when my mouse is moving. I want it to happen every frame. But I just want it to run every frame. Come on. Maybe I need to ask for it to wait until... Oh, it's checked ahead, okay. There we go. It's happening at a regular refresh right now. Okay, this is the basic thing I wanted. Now I can like make the particles. Oh, that took more than 2 hours, but I have particles moving around now. And this is what does it. Takes the previous position and it adds vector 1, 1 to them. So, before I do full-on Boids, what's something cool I can do? I may as well just go ahead and do Boids now. Okay, close all this. So, what is a Boid? I know there's like 3 things that they do. There's separation, alignment, and cohesion. So I might need to have more state than just a position for like actual Boids. I think they need to have a direction. So maybe I should just have like, I could just do like a gravity thing or something for now. If I'm already going to be doing n squared style, I might just do n squared gravity. So yeah, I'll do that for now. So for int equals 0 is less than 1024. So for every particle that's not me, I'm going to experience an attraction. Oh, this records velocities too anyway. So yeah, I may as well just add a velocity buffer, or maybe just make the buffer twice as big to pack velocities next to each other. That's easier, even if it's maybe not the best decision. For now it's gonna be 2D, yeah. Yeah, I can make them 3D in a bit. I'm just gonna get it working 2D because right now I just have 2D positions. Okay, so four of these. Yeah, it would actually make a lot of sense to have a separate velocity buffer because I don't need to double buffer it because I don't actually think I do because Boids need to look at each other's velocities. So yeah, I do need to double buffer, so I may as well just have my buffer store all of them next to each other. Alright, so it's going to have vec2 velocities, and I won't use these here, but I will use them in here, velocities in, velocities out, constant indexes. Okay, so I may as well just make these sized. Yeah, that's another problem. If I had them as different buffers, I could have them unsized, but for now I just need to put the size. $65. This is for my draw program. Yeah, this also needs to just be fixed size. Okay, so it's still working. Good news. Okay, so for now I'm just going to do attraction, inverse squared. So I'm going to loop over every single other guy. If its ID is different from mine, I look at the position. I take the position. Okay, and then I need to make my velocities updated from... Okay, so I'm just going to have this do nothing to start with. Output velocity equals input velocity. Output position equals position. So I'm going to compute a force from the sum of all of the distances. Okay, so I can compute distance by that's the distance. I'm looking for squared anyway, so I also need it to be along the vector, so I can actually say so this is it's going to be divided by this with some multiplier that I'll figure out. But this is the inverse squared distance, and then it's going to be in the direction of other, so it's direction of dir, so I'll do like velocity plus equals the direction divided by inverse squared. It'll probably blow up if stuff's too close, but I'll figure that out later. And then I'll just say plus velocity and figure out the multiplier on that too after trying it. I think it blew up instantly. So let's just, if we don't do this, it's still there. If we do this, let's just do like very small multiplier to see if it's like getting nans. I think it's getting nans like right away. Let's test that in RenderDoc, see if that's actually a problem. I think it probably is. Okay, so the draw thing is taking in my particles. Let's go to the particle. Yeah, this isn't ends. That's what I thought. Okay, so maybe we can catch the first iteration and see what's happening there. Q capture on frame 0. We've captured clamp velocities. Yeah, that's a good idea. I could also use the GEM-UXL light fall off method for my inverse square fall off. If I wanted to. Okay. Yeah, my velocities are nan after the first thing. Inputs are fine. Outputs are nan velocities. Every single one is nan. So what am I doing? So like I'm assuming it's because direction is 0. Maybe I can just set velocity to direction and see what happens. Birds can only fly so fast, that's true. launch. Okay, first dispatch pipeline state, compute shader output. So yeah, all of the dirs are 0 for some reason. Or at least one of them is 0. But I mean, it's the... pretty much all of them gotta be 0 for this to be 0. Why would that be happening? Other is positions in I. Let's try setting velocity into other to see. Oh yeah, this is gonna... I've got to close it before I build again. Okay. Let's launch it again. Pipeline state, particles out. They're all 0. So it's only getting, but like the inputs aren't 0. Particles in. Maybe, okay. It must be reading zeros from the velocities when I try to look at positions in. But like velocities out is working. I don't know if this is a problem with RenderDoc or if it's a problem with my format. Okay. I'm a big dummy. I'm explicitly interleaving them here. And then this is not interleaving. Yeah, every other one is 0 because that's how I set it up in the first place. So, I am gonna just instead... Yeah, this is what I should have done. Just messed up the data layout, basically. Yeah, so now I have all of the positions, then all of the velocities next to each other. And let's pull it up in RenderDoc again. See what's up. Pipeline state, output. Why does it not even have position out? Members skipped as they are fixed size. Well, I think it'll work now, so... Yeah, let me just give it a try making it back to what it was. There we go! There we go! I'm so happy. Finally got this to work. These aren't even voids, this is literally just inverse squared attraction. Really happy with this. just gonna sit and watch this for a bit. It's cool. They were like in several different clusters or like galaxies or whatever, and they're kind of like there's only one now. I think it might still be getting nans. Like it doesn't look like there are fewer particles, but if two particles ever land on the same exact float value, they would get. I guess that's not very likely. It's squared. I'm just computing like this is distance squared, so yeah, it would be cool to get like put them in spirals and then have them have initial rotating states. Okay, I'm gonna start it again and see what happens. That's so cool. I love that like first few moments where they slingshot past. My version of the Pauli exclusion principle is that if two particles ever have the exact same floating point coordinates, they instantly get nan coordinate values the next frame, and they cease to exist. Using star position data, that's a really cool idea. Do you remember that, Lewis, you sent me that Twitter post of like somebody talking about buoy data of ocean elevation and like turning it into auditory range? That's something I still want to do. How closely did that track to like actual astronomical data? I mean, I guess if it's like the current positions, you'd have to wait a long time to see how correct you were, I guess, but very happy. I'm gonna commit this for now. Kind of running out of steam, I think, so I might just commit this and continue next week. I don't have any Boyd behavior, I just have gravity behavior. Crumbly mist. Where are you, trailing white space? Where was it again? After that bind buffer base. Get out of here. Oh, my phone is also about to die, and that's how I've been looking at chat, so maybe I should go get the charge cable. Anyway, yeah, I'm gonna commit this for now. I don't know why Git GUI always does this to my terminal. It just like spams control characters. Anyway. Okay, I have a particle sim. Oh yeah, dog. Before the stream ends, I will get dog. I'm gonna be right back. I'm gonna get a charge cable so that my phone doesn't die. You forgot I existed. I love the Git GUI. It's like, okay, I'll go get him. I actually love the Git GUI. It's like janky. It's like janky ancient GTK, but it's also like way more no nonsense than like a full on modern Git GUI client. Yeah, she was. Yeah. Like I don't use it for like general repository interaction. I just like use it to stage changes because it's faster than like you doing like the patch splitting stuff on the terminal. Like you can just select lines and stage them. But yeah, see now it's got like control characters all over my command line. So GitK is the other janky GTK thing. That is good for actually exploring repository history, and like they both come with Git, and I don't really need anything else. Yeah, GitK is nice to have. And yeah, it's also definitely a Windows problem. Like this is the PowerShell terminal, so it's probably just not interacting well with it. Okay, it's dog time.
Sleepyhead. Do you want to come say hi? Do you want to come go with me?
Hey, sleepyhead. We took him to daycare twice this week, and then he went to the park this morning, so he's been kind of worn out. Which is good for while I'm streaming, but... Buddy, the internet's watching you. He doesn't understand screens at all. Like, if I show him, like dogs on screen, he, like, his eyes focus somewhere else. Like, oops, just knocked into my webcam. His eyes focus somewhere else. He, like, fundamentally doesn't understand what a screen is and how it works. If there's barking audio, on the other hand. Anyway, I'll let him go back to sleep. Yeah, I hope you enjoyed the Hubble content. Sort of thematically related, because Hubble telescope, you know. Anyway. Next thing I want to do the actual Boids thing, but I also want to do some, like, anti-aliasing, depth of field and motion blur stuff. But I probably want to do that once I want to make this actually in 3D instead of 2D. But yeah, I think that this is a pretty enough result that I can call it a week this time. Oh, you didn't see the results? Yeah, let me bring this up again so you can see. That was funny. There were like 6 of them that got ejected at the beginning. Okay, I actually want to change the starting positions to be like within a circle instead of a, which I'll just do rejection sampling for that. So Oh, it should be x minus 0.5, yeah. So while it's outside of the circle, resample. So this will ensure that they're all inside the circle. Oh, multi-cursor, yeah, that's like my favorite Sublime text feature. You just like, you can either control click and then type simultaneously, or like if you have a symbol and you want to edit every occurrence, you can do Control D and go, it selects all of them, and then like I can rename the word particles to something else. And like the nearest Vim equivalent is like %, you know, to like rerun a command. Oh yeah, and you can also, depending on the OS, like on different platforms, the shortcut's different. You can do like a box select with middle click drag, or it's also like shift right click drag, and then it's multi-cursor on each line. Anyway, yeah. Probably like my #1 feature I would never use an editor without, I think. Or at least like some decent equivalent too. Oh yeah, let me see if this actually worked. It did not work. Wait, yeah, I needed to be 0.5. I'm rejection sampling to within a circle that contains the entire screen. So what is wrong? It's never failing, so that's a clue. It's getting a random, and then x minus 0.5 times x minus 0.5. Okay, I guess let me just print this out. Why are they never... Oh, 0.25 because it's a squared distance. Got too clever. Yeah, there we go. That's a little circle. I'm gonna make the window be square, so that it's not an oval. Yeah, it was just a squared distance. Okay, where else in my project do I have the window size hard coded? I think that's everything. Yeah, so 800 by 800 now, except the place I was generating the particles. Here we go. I think technically the compute shader, when the particles are off screen, it's just yeeting them out of bounds in the array, and I hope that's not like... I could make it full screen. Oh yeah, like a rotational velocity thing. That should be easy. Okay, so I have x and y, and now I'm gonna make their velocities be -y, x, and that might be too big. But we'll see. Maybe they're too small actually. Oh, you know what? I'm multiplying by 0.01, so that would make sense. Let's multiply them by 100. Yeah, the physics is like roughly gravity. It's it's inverse squared attraction from each thing to every other thing. So yeah, like Newtonian high school physics 1 gravity with it's just forward Euler. So that's pretty cool. Let me try speeding it up a bit more. Did that work? That didn't work. That did the opposite. Oh, because I wrote, okay. Oh, you know what? It should be actually negative y minus 0.5. That's what it needs to be, because these are origin at the corner of the screen, not the center. Yeah, I could use relay. I need to look up how it works again. I forgot everything about numerical integration also. Okay, this is cool. They're like doing some cool clusters. Yeah, this owns. A cube? Is what a cube? I kind of want to do like a very simple anti-aliasing algorithm. So I'm gonna rather than just splatting one value to the screen in the draw shader, I'm going to do at the beginning, yeah. Yeah, kind of, yeah. It's not on GitHub. I think I kind of want to clean this up a little bit before posting it anywhere, but yeah, I've been committing it, so I can put it up on GitHub. Yeah, this code is not the most hygienic I've ever written, but yeah. Okay, so I'm just doing one atomic add. What I should instead do is find the suppose this is like a 1 pixel radius circle. I'm going to find the 4 pixels that intersect that. And then for each of those, I'm going to do like, based on the distance from the point of that pixel center, do like a distance field fall off. Yeah, I'll play this with the GameCube startup song. Yeah. Okay. So I need 4 of these, and they'll be at so I have my position. I'm rounding it here, so what I should instead do is yeah, if it's like a 2 pixel wide circle, so it's a 1 radius circle, it always will fit in 4 pixels. Let me open just an image editor just to like mock this up. So suppose I have, this is a pixel grid. This is one possible configuration. Let me use the line tool, idiot. Okay. So if I draw a circle, this is one possibility. Oh, that's a selection. Okay, circle. Okay. That's one possibility. And then, okay, it can overlap more than 4, I suppose. Oh, right, if it's only this big, it can only overlap a maximum of 4 pixels. And if I have the value of its center, then if I round it, I get the pixel that its center is inside. What I really should do is find the minimum and maximum coordinates of the containing square, round those to the pixels that they're in, and that gets me the 4 pixels I need. So if it's here, minimum coordinates are here and maximum are here. Wait, I can just find the minimum one, and then that's the upper left of my 4 pixels. Okay, here we go. Oh, the anti-aliasing techniques? Like FXAA, TAA, those kind of things? Is that what you're asking? Okay, so those are just like, do you know the basic concept of like band limiting and like sampling a signal, and like how you get aliasing if you sample below the frequencies of the signal? To use less math words, it's just like if you have each pixel either part of one triangle or not part of that triangle, and each pixel has only one color of a triangle, then it has jagged blocky edges, right? Okay, yeah, the Shannon paper is good. I think there's also like pretty accessible explanations since then, but yeah. Basically, it's just if you look at your scene as a signal, it's got infinitely high frequency discontinuities at the boundaries of triangles. So you need to band limit that before you sample it, or else you'll get the jaggy edges. So like what you should have is like, if you're using a box filter, which is just like, yeah, I'm not gonna do like the full explanation of like every image anti-aliasing thing that I could go on about. But just like the basic problem that we're trying to solve is, if you draw a triangle on screen, if you only test whether the pixel centers are inside or out, you get aliasing. But if instead you calculate the area overlap of like the triangle polygon with the square polygons of the pixels, you get pretty nice looking anti-aliasing. And that's the way that most like font rendering uses. They use the box filter technique, and so that's basically what I'm doing. But I'm using an approximation here where I'm just calculating circle coverage by pretending the circle is actually, yeah, box blur is that. Like box blur is where you take a rectangle and average with a flat kernel, average all of the pixel values within that box shape, where you multiply the signal by the sampling instance. Kernel is like, it's like if you have a matrix, I'm thinking of a kernel as like the data inside the matrix. Or like for a continuous convolution, I'm thinking of a kernel as like the thing you're convolving with, if that makes sense. So you multiply the signal by the sampling instance, and you can see the flipped signal in the frequency domain at fs times 2. I actually don't think I've seen that one before. I can imagine it. So you mean like multiplying it by the Dirac deltas? Yeah, I'm gonna have to. If you have a link to that, please share, because I don't think I've seen that exact one. Yeah, there is a matrix that finds edges. There's like the Sobel filter. There's there's a bunch of them. Edge detecting filters are there was a joke my computer vision professor made that like the best way to get your name like well known in the field is invent an edge detection filter, and then there will be the like so and so filter. But yeah, because there's a bunch of them. Okay, so getting back to what I was doing, here's my position. My radius is going to be 0.5. So this is the upper left corner of my bounding box of my circle, and I'm going to take this, and then I'm going to say, I'm going to round upper left to be pixel, edit to, so now I'm going to say draw it at px, and then so now I'm going to draw, and I think right now this will just give me a proper flat 2x2 square. Yeah, so that's working. Let me, yeah. So this is not anti-aliasing, it's just a 2x2 square. And now what I need to do is, instead of just writing 1 here, okay, so I'm going to have to start using larger values than 1 so that I can have like different coverage values. I'm going to change this to be dividing by, let's say that I have 256 coverage values. So I'm going to divide by 256, and then I'll put the integer 0 through 256 for the coverage value, and the coverage value is going to be I've got to get this point back out and add 0.5 to it and then calculate the distance. So let me just do this in a lazy, hard-coded way. So this is my center, and then now I need to do distance between this and actual position, and then that distance, if the distance is 0.5, no, yeah, if the distance is a full 1 pixel, then it should be 0. If the distance is 0.5, it should be 0.5 coverage. So yeah, let me do just like a clamp. Let me just do smooth step. Oh, okay, just smooth step. Okay, so it's smooth step from negative 0.5 to 0.5, I believe, with this distance value. And then let me just copy paste this 3 more times with these different coordinate values. I think my favorite thing is that the clipboard is multi-cursor. So you can just do that. Oh, it's a float. Yeah, I need to multiply this by 255 or 256, I guess. And then cast it to integer. I guess uint. Yeah. Okay. I don't think it's actually working. Maybe because I think it's just overblowing it. But okay, so let me look in RenderDoc again, see what actual values it's putting in the buffer. Oh yeah, launch application. Do not queue a capture. Smooth step is not an appropriate kernel function here. It was just less typing to write smooth step than the clamp and add. And the only defense I have for smooth step is it's built in and it's smoother than the actual, than like clamp alias is slightly more. But smooth step actually has the wrong range for a radius. Like smooth step is Lindy. Okay, so here's my input texture. What kind of values am I getting? So it's just getting 256s. Nowhere is getting less than 256. So that would explain it. My distance value is, I guess, just always bigger than that. Anti-aliasing is the idea. Well, okay, so it's the more general concept is filtering, and interpolation are like the two operations for when you're going from a small amount of data to what's like imagining what's between it is interpolation, and filtering is when you have a large amount of data and you're trying to summarize it down to a smaller amount of data. And if you're like filtering in general is the concept of like changing, like resampling the sample rate. So yeah, if you just naively don't do a good job of sample, I mean, there's no way to go from a large amount of data to a small amount of data and back and not lose anything. Like fundamentally, obviously, like pigeonhole principle wise, like you will lose data by crunching down and going back up. But there's situations where you can avoid losing anything. Like there's a. I'm gonna get this working right now. Next stream I can do like a better anti-aliasing chat. But I need to think about this more for like what's the best way to explain it. Let me just multiply this by 1 and see what values I get instead. Yeah, so it's very faint, but let me get it in RenderDoc again. Launch application. That print is annoying me. I have all these debug prints that are like causing a second of delay when I load the program. Okay. Oops, wrong program. Okay. RenderDoc. I could be integrating the area of the disk, but like it's just smoothing it. Basically, since I'm pretending that the disk is so large that it is a half plane when restricted to the pixel, which is obviously a bad assumption because it's the size of a pixel, but like it will look better, it will look smooth. Like it won't be anywhere near a correct. I mean, this is slightly different. Like I'm doing like distance along the vector from the pixel center to the point center. So like I've got to round it to find it on the pixel grid. I wouldn't doubt that I'm doing it in an overcomplicated way. I'm just trying to get this to work. Okay, pipeline state, image, go. So what am I getting? It's all 1s and 0s. Well, that makes sense because I'm multiplying by 1. Okay, so let's try not doing the smooth step. Yeah, the thing is I can't turn MSA on in this situation because I'm not using the rasterizer at all. Yeah, if I were like drawing these as little circle meshes and using MSA, I could do that. But yeah, this is just atomic adds into a buffer, so okay, so let me think about this. Distance from the pixel center cast to a float vector plus 0.5, 0.5 for its pixel center. Distance from that to the position, which probably varies from... Wait, yeah, I'm stupid. This is a... Okay, distance needs to be minus 0.5. That's what it is. Still not working. But I think it's got some half tones in there. Well, it's assigned distance. Like I'm subtracting the radius. Okay, let's render doc again. Okay. Image. Yeah. Okay, so looking here, we have... Okay, we actually have like a range of values happening. So that's pretty good. They are not ranging from 0 to 256. And so I think probably my grid math is wrong too. I'm not sure because a lot of these have full 2x2 blocks, but yeah, okay, so smooth step should be between 0 and 1. What? So why is it not? I forgot smooth step. Yeah, I will try a million particles. Yeah, this, I mean, I haven't timed this with the loop over all of them, but last time it was like under a millisecond when I was doing like 4,096 threads, and then I had like a loop that was like thousands long in the loop. So I'm pretty sure I could do a million just fine. Reverse engineer an initial Boyd state. It's possible. Boyd's is like really... That seems difficult with Boyd's. Like with gravity, maybe. I mean, gravity is probably a lot easier. I mean, I'm sure that's a well-explored question for Newtonian gravity, but... Yeah, so there should be a value between 0 and 1. Yeah, I think, yeah, gravity should be time reversible. Boyd's, I actually have no clue if that's time reversible. It's like very non-smooth because you have like a, it's not like a fall off like with gravity inverse square. It's like you either have like a fixed number of neighbors or you have like a fixed radius of neighbors that you look at. So it's at least like very non-smooth. So I don't think it's likely that it's reversible, but okay. Just want to get anti-aliasing working. Okay, not gonna do it this way anymore. Killing smooth step. Oh, what happened? Okay, so I have my distance, and the distance should be ranging from I'll just clamp it. And then it should be 1 minus the clamped distance. Okay, that looks more like what I wanted. I think I actually need it to be, if the distance is 0, it's fully on the pixel. Okay, yeah, this is not like correct or whatever, but it looks cute, I think. Okay. Oh yeah, so this is 0 to 256, and I'm dividing by 256. So that's properly what I want it to be. And they look nice and soft. So yeah, I'm happy with this. I could make it like a slightly bigger neighborhood, like more like a 3x3 splat. But yeah, I think this looks good. All right, I think that I am. $255 rather than $256. Yeah. I will multiply by 255 and divide by 255. Not like it makes a big difference here. Anyway, the request was to increase 1024 to 1,000,000. I'll use this number because it's part 2 for no reason. Oops. And then in my shaders, I have it hard-coded. And that's all of them. This might be a problem. I think it might be too slow. Okay, so let's actually try something more modest. Let's replace this with 4096 and see what's up. It's understandable that it'd be too slow because like my algorithm is n squared. So like it's understandable. If I did some binning thing, Sintel was doing a simulation where the Barnes Hut, yeah, that's what it's called. I could do Barnes Hut. I actually, this would be going further off the track of Boyd's, but I might just do Barnes Hut next time. Like with Boyd's, my plan was get it working with n squared and then use some grid binning thing. Because Boyd's has sharp fall off, so like you could do a perfectly correct one with only considering a small neighborhood, but with there is no octree here. We're talking about the possibility of an octree. But yeah, so Sintel mentioned Barnes Hut, which is basically you have an octree for gravitation. So obviously, since particles, every particle influences every other particle, since inverse squared never goes to 0. What you can do instead is take a subtree of the quadtree. If you're not inside it, you don't loop over every single point or mass in it. You instead summarize it with either like a total mass value with center of mass, or like some kind of moment approximation, or like multipole expansion. Nice. Um, I don't have a view of the stream up, but I will look at the Twitch compression. I will screen record. I'm gonna be posting videos of this after the stream is over. Yeah. Okay, Sintel, you are saying it is not R squared. Okay, so are you basing that on this code? And you're saying this is not R squared? Like video compression, right? Oh, you're right. Okay. Yeah, let me do normalized dir, and then the thing is, if this is length of dir squared, yeah, you're right. This is just over R. Okay. Let me just calculate this. And then that should be it. Okay, let's see what it actually looks like with inverse squared. Is this what it's supposed to look like? Okay, so apparently I'm doing it wrong still. I mean, Swan, you know, like the notion of video compression, yeah? Like, they're not just sending pure blocks of pixel values over Twitch or over YouTube. Like, it's like modeling the 8x8 blocks with some kind of regression thing. So, like, it does a bad job with highly noisy stuff, yeah. Okay, so let me think through this again. Let me just stare at gravitation. This is just like the physics 1 Newtonian gravitation. G m1 m2 over r squared. Yeah, it's vaguely like that. Yeah, they do like JPEG in particular uses discrete cosine transform, which is similar. And then I'm pretty sure they do that, but also have like motion related stuff for video. I don't really know the details of video compression as well. Okay, this is the law. So force is, and the vector form is m1, m2, since all the masses are 1, that's just 1. The vector r is so you think it's correct right now then? Okay. Is this really what it's supposed to look like? Okay. Alright, let me make it go even faster. This is boring. Well, I guess my opinion now is that inverse distance attraction looks cooler than inverse squared. There's cool slingshotting happening here, though. Okay, so this is not correct, you think, Centel? Oh, you did say yep, that it's correct, and it doesn't look as cool. Alright, I'm gonna have to... But yeah, I should make this 3D sometime. But yeah, I'm gonna turn this back to the wrong one, the inverse fall off instead of inverse squared for my video captures, because it just looks cooler. Trying to think if there's some scale thing I can adjust for this. Like, I have a pretty fast update speed. And the update speed is the same factor as, like, any kind of gravitational constant or masses. Like, so it's basically update speed that it's up to. Let me try reducing num particles again. Or maybe I can just reduce the radius of the spawn circle. Artificial friction to, like, slow them down, yeah. Is that... So would friction be exponential decay on the velocity? Like, velocity just multiplied by... like 0.9 or 0.9 or something? Or is it like... Let me see if this is horrible. Interesting. It's a pretty fast decay, I guess, yeah. Let me do less of a decay, because these are like... This is like interstellar medium made of, like, jello or something. They really just go off the screen so fast. So you think this would look cooler in 3D then? I'm gonna put back in the initial velocities just at a much smaller level. And see what's up. Yeah, that makes sense. A lot of potential energy. Okay, let's make them bigger again. Okay, one last thing. I want to time how long this update step is. Let me go plunder my other project. Copy paste for query timing. I do this like so many times in my life. Okay, so I'm just gonna do the actual update. The draw part is like negligible probably, so oops. Oh yeah, it should just be around the dispatch compute. So Oh yeah, kill this. Yeah. Okay, so it's actually taking like 3 milliseconds, which is not negligible. I could probably speed that up a lot with Barnes Hut or something. But that'd be like another compute kernel for like building the Barnes Hut quad tree. And then another buffer to store that, and it'd be pretty complicated, but it'd be a worthwhile project. Anyway. Yeah, I have to say, the videos I'm uploading are going to be from the inverse fall off, not the inverse squared fall off. It's way too fast. This is fun. Okay. So yeah, we've stress tested it. I think that even doubling this would make it not be 60 FPS anymore because it's n squared. But this is like a decent number of particles. It's not that many. Anyway, I'm pretty happy with where we got to. I got like particles moving around. Had all these Boyd papers. I had this paper loaded up because I really wanted to get some like murmurations going on. But maybe I'll do that next week after I actually have moving particles going. Finite radius, yeah, that's a good thing to try. Anyway, yeah, I think I'm done trying stuff for this week's stream though. Gonna get it back to where it was that I liked. That's cool. That looks very cool. I think this is faster than I had it. Where's my initial velocities? I'll make them back to 300. Yeah, those cluster structures are really cool. It all really just does settle down into one though, pretty quickly. Oh, you know what? I forgot that I had the... That's what happens when you have the friction on. Yeah, this is without friction. That's very cool as well, but the friction makes it cluster in such a cool way. Oh, your Vorton sim does, yeah. I mean, yeah, it just does look better in 2D. Oh, so what changed was, okay, here is, I'm turning off friction. And now here's how it was the last time, like earlier. So now I'm turning friction back on, and I get this like, it's like more aggressively, like tightly clustered because of the friction. And it gets this like really cool spinning, crazy thing at the end. So yeah. Without friction, I think is like, yeah, it's inverse distance. Okay, this is gonna be my video for what I accomplished this stream. Pretty happy. I did do some anti-aliasing. I do want to make these 3D and then do some like depth of field and motion blur stuff. Okay, so yeah, I think I'm about ready to call it a stream, but I thank you guys for tuning in. Running from T equals, yeah, let me start it again. It's always fun to watch. But yeah, thank you guys so much for tuning in again. Means a lot. I hope people enjoyed it. I hope people learned something if they didn't already know everything I said. But yeah, this is kind of what I wanted, just like pretty dots flying around in space. So anyway, yeah, I think I'm gonna sign off, but I'll be doing the same thing, same time next week. Anyway, thanks for tuning in.